In this part of the lecture, we are going to do 5 important points and 5 important lines in any triangle. We will describe it clearly about 5 important points in a triangle as well as 5 important lines. Is it clear? We will discuss about 5 important points and 5 important lines of any triangle. Let us say ABC is a triangle, right? Now, if we join any vertex with the midpoint of the opposite side, then that lines are what called your median. Okay? Now, we can easily see that there can be 3 medians in any triangle, and these 3 medians will intersect at one point. That is, these 3 medians will be concurrent, and this point where the 3 medians are intersecting is what called your centroid. Is it clear? So, this is the first important point, which is called the centroid, and the lines are what called your medians. Is it clear? So what is a median? Median is the line joining any vertex of any triangle with the midpoint of the opposite side is called medians. There are 3 medians in any triangle and they are concurrent. That is, they are meeting at one point, and that point is what called your centroid. Is it clear? Number 2. For any triangle, we can have 3 angle bisectors, right? This is the angle bisector, this is the angle bisector, and this is the angle bisector. Okay? So here AD is the angle bisector of angle A of the triangle ABC. Angle BE is the angle bisector of the angle B of the triangle ABC. And FC is the angle bisector of angle C of the triangle ABC. All the angle bisectors of this triangle ABC, they will always pass through a point. That is, all the angle bisectors will be concurrent. And this point is what called your incenter. Is it clear? So the angular bisector or angle bisector of any triangle will meet at a point, that is, they are concurrent, and that point is what called your incenter. You see, if we take the incenter as the center and taking the perpendicular distance from this point, from the incenter or from any of these 3 sides, if we take the perpendicular from any of the 3 sides and taking that distance as the radius, if we draw a circle, it is going to touch all the sides of the triangle. This circle is what called your incircle. Okay? And the radius of incircle is generally denoted by small r. Is it clear? We have learned that thing now. Circumcenter yet we have not done. Okay, that we will do. So this small r is nothing but the radius of this triangle ABC. Is it clear? So this r is what called your in radius. This is what is called your in radius. Is it clear? So this is our second important lines, which are the angle bisectors, and the important point is what called your incenter. Third one. Let us say another triangle ABC. Now if we draw the perpendicular bisectors of each side, again they are going to meet at one point. Okay? So all the perpendicular bisectors of any triangle meets at one point, that is, all the perpendicular bisectors are concurrent. Okay? Now, this point is what called your circumcenter. This point is what called your circumcenter. So, in a triangle, we are having three perpendicular bisectors which are intersecting at one point, that is, all the perpendicular bisectors are concurrent, and that particular point through which the perpendicular bisectors are passing is what called your circumcenter. Okay, now from circumcenter, if we take the distance from any of its vertex, from this circumcenter, if we take the distance from any of its vertex, taking that distance as a radius, if we draw a circle, it is going to circumscribe the triangle ABC. Is it clear? It is going to circumscribe the triangle ABC. Now, this distance, if I take this thing as my C, then CB, that this distance, or CA or C we have already taken. Let me just take this thing as, say, D, whatever. So your DA, DB, DC, they are nothing but the radius of the circle. This is what is called your circumcircle. Is it clear? This is your circumcircle. Okay? And this radius is what called your circumradius. Circumradius. Is it clear to all of you? Generally it is denoted by capital R. Small r represents the in radius and the capital R represents the circumradius. Is it clear? So, first one we have learned what is a centroid. That is the point where all the medians of the triangle are intersecting. Next we have learned what is the incentered. That is the point where all the angle bisector of the triangle are meeting. Then we have learned what is circumcenter. Circumcenter is the point where all the perpendicular bisectors are meeting. Is it clear? Okay. Next, the fourth point is, in a triangle ABC, we can draw, look at carefully, we can draw three perpendiculars from the three vertices on the opposite sides. We can draw three perpendiculars from the vertices of the triangle on the opposite sides. Now these three perpendiculars again, which is going to pass through a single point, that is the three altitudes or the three perpendiculars will be always concurrent, and this point is what called your orthocenter. This point is what called your orthocenter. Is it clear? So what is an orthocenter? The point where the three altitudes of any triangle are meeting are called your orthocenter. Okay. Now, the fifth important point is, in any triangle, if we just produced, let us say ABC is a triangle. Now, if we just produced AB and AC, and if we find out the external bisector of angle B as well as the external bisector of angle C, they are going to meet at a point which is called your excenter. Which is called your excenter. Is it clear? So if we produced AB and AC, we are going to get one excenter. If we produced BC and BA, again we are going to get another excenter. And if we produce CA and CB, again we are going to get another excenter. So for any triangle, we are having three excenters. Is it clear? So what is an excenter? If we produced any two sides of any triangle, and if we take the external angle bisector of those angles, they are going to meet at a point which is called your excenter. Okay. Now, this angle, this is what? This is the exterior angle. Now, B, let us just say this one is, say, I1. Okay. So, BI1 is basically the external angle bisector of this angle. Okay. Now, if I join this eccentre with the opposite vertex of the triangle, remember it very carefully, if we join AI1, then AI1 will be the internal angle bisector of angle BAC of the triangle ABC. Is it clear? So when we are going to join the eccentre with its opposite vertex of that triangle, that line will be the internal angle bisector of that angle. Is it clear? Now, so what we have learned? We have learned that in any triangle we are going to have three eccentres. Now, this eccentre, let me just denote it by I1, let it be denoted by I2, and this one, let us say I3. Okay? Now, taking this eccentre, that is at I1 as your center, and the perpendicular distance from any of these three sides, either from this side or from this side or from this side. If you take that perpendicular distance and take that thing as radius, if I draw a circle, it is going to touch all the sides of this triangle. All the sides means this side is the side of the triangle and this side is the external, the produced side of AB, as well as this side is the produced side of AC. Is it clear? So that is going to, this circle is going to touch all those three sides. Similarly, in this case also it is going to touch all those three sides. In this case also it is going to touch all the three sides. These are what called, that is, these circles are what called your X circles. Okay? Now the radius of the X circle, which is opposite to angle A, this is a general notification we have to remember in this way. We cannot change it. The radius of the X circle opposite to angle A is generally denoted by small r suffix 1. As well as for this one which is opposite to angle B, this eccentre I2 which is opposite to angle B, the radius of that X circle is generally denoted by R2, and for this one as R3. So R3 is the radius of the X circle opposite to angle C. R2 is the radius of the X circle opposite to angle B, and R1 is the radius of the X circle of the triangle ABC opposite to angle A. Now, if you observe, you will find that for your centroid, circumcenter, incenter, orthocenter, we are all having, for any triangle, we are having only 1 point. Okay? Centroid, 1 point, incenter, 1 point, circumcenter, 1 point, as well as your orthocenter, 1 point, right? But in case of any triangle, there are 3 X circles. There are 3 X circles. Is it clear to all of you? Have you understood these 5 important points and 5 important lines of any triangle? Okay.